Episode is going to be a detailed explanation of all you need to know to pass JAMB, to score 90 and above. So if you are just joining us for the first time, or this is the first time you come across this channel, please don't forget to subscribe to this channel and follow up these classes, because I'm going to be giving a detailed explanation of most likely JAMB questions, repeated questions. Do we understand? And I'm going to make sure you understand this so that when you see it in your forthcoming exam, you can be able to write it and be sure that you actually did something. So with no further ado, let's get right into the video. Now I'm reading through the past question. The question says, the value of x, y, and z, respectively, in the expression m power x, l power l, and t power z for the universal gravitational constant G are dash. You can see the options below, okay? We have option A, 2, minus 3, minus 2. Option B, minus 1, 3, minus 2. Option C, minus 1, 2, minus 3. Option D, minus 2, minus 1, 3. Do you understand? So we're going to analyze this question. Now look at it. It says, what values of x, y, and z is equivalent in gravitational constants? Now you ask yourself, what is universal gravitational constant? That is going to lead us to law of universal gravitation, because it was from there we are going to be able to pick and get our gravitational constant. I hope you understand. So let's just go into the law of universal gravitation, which states that what? F is equals to gm1 m2 over r squared. Now from this particular question, what you're looking for is this. That is G, right? So we must make it the subject. That is the first thing. Remember that F is our force and M is our masses. We have two masses, M1 and M2. Then this is distance separating the two masses in the universe. Okay? So let's go. By making it the subject, we're going to say cross multiply. So watch what I'm going to do. I'll say this is over what? 1, right? Then I say cross multiply. Okay? Now I have gm1 m2, because this whole numerator we multiply by 1, okay? Then is equals to fr squared. Hope you are getting this now, so please pay attention. Now what I'm going to do, because we want to get the dimension of G, so let's divide both sides by m1 and m2, okay? So we divide both sides by m1 m2 m1 m2. Do we understand? Now this cancels this, so we have that G is equals to fr squared over m1 m2. Do we understand? The next step we're going to take now is this. This force is in Newton, but we have to get the units of force, so you can help us get the dimension of force. Now if I break it down to say that force F is equals to mass multiplied by acceleration. Now what is my mass? My mass is what? Kilogram. My acceleration is what? Meter per second square. Okay, so I have meter per second square. Do we understand? So that becomes the unit of what? Force. So I can as well put it here and solve my problem. Okay, now we have this unit of force to be what? Kilogram meters per second square. Then multiply by the distance is what? Measured in meters. So there is meter square. Okay, now the masses are measured in kilograms, so I have kilogram square. Do we understand? Now from the law of indices, this kilogram is coming up and the power is going to change to be minus 2. Do you understand? Okay, so this is G is equals to kilogram. Now this is meter raised power of 2 and this is meter raised power of 1. I'm going to bring them together, right? From the law of indices, I'll say this is m plus 2, right? I hope you understand. Now per second square. Now this is kilogram minus 2. Let me bring them together. G is equals to kilogram. This is 1, okay? And this is minus 2. So this becomes 1 minus 2, then m power 3 and x minus 2. Do we understand? So that gives rise to G is equals to kilogram. 1 minus 2 is minus 1. Okay, then I have m power 3 and I have x power 2. Do we understand? But you must remember, we are getting the dimension. These three letters are very important. We have m, we have l, and we have what? T. These are the three form of dimension that is generally accepted. Okay, now from this question we are giving this as x, giving this as what? Y, giving this as what? Z. We are asked to find the values. So let's go. Now what you are going to do now, this is kilogram, which is units for mass. So you're just going to write, transform it in dimension to be m power minus 1. Now this is length, units for length. Okay, we are going to just transform it to have what? L power what? 3. Okay, now this is seconds, units for what? Time. We're going to transform it to be what? L power minus 2. Is that clear? Now if you relate it to what we are given in that particular question, because this is the units of G, now we can use this to get the dimension of G, which is what you are looking for. Do we understand? So with that, we are going to say that this is m power x is equals to m power minus 1, right? Now from the law of indices, the bases are the same, so we can work on the power. So if you cancel this, automatically my x is equals to what? 1. Is that clear? Now we have my l raised power of y is equals to l raised power of what? 3. So by the time you cancel this, so what happens? My y automatically is equals to what? 3. Okay, so we have t raised power of z is equals to what? T raised power of minus 2. So if you, this is z, right? So don't get confused. If you cancel out, you have that z is equals to what? Minus 2. Is that clear? It's as simple as that. So I can say that my x is minus 1. Sorry, this is minus 1. Okay, my x is minus 1 comma, my y is 3 and my z is minus 2. Is that clear? Now from what we got so far, the correct one that has the same answer as this is option what? B. And that becomes the answer. So in case you see this particular question or something relating to this question in this your forthcoming JAMB, you should be able to solve it. I hope that is clear. Now let's look at the next question. The diagram below shows forces 3 Newton, 10 Newton, 3 root 3 Newton and 6 Newton acting on the particle P. Okay, now pay attention. The resultant of the four forces is what? We have the forces shown on the diagram, and we have option A 10 root 3 Newton, option B 10 Newton, option C 3 root 3 Newton and option D 5 Newton. We are simply going to resolve this. Okay, now this is resultant of more than two vectors, so what you are going to do is to resolve them into the horizontal and vertical components. So how do I mean by that? So let's go. Now we say that this is what? 3 Newton. Now any vector that is on the horizontal axis, it is inclined at 0 automatically, even though the angle is not given. Okay, and at this point, this is where the maximum vector is being achieved or is being gotten. Do we understand? Now any vector that is inclined in the vertical, automatically it is inclined at an angle of what? 90 degrees, because this is what? A perpendicular vector or a right angle vector. Do we understand? Okay, so let's go. So we're going to use this. Now this is what? Positive x and this is negative x. Okay, let me put plus here. Do you get it now? Now this is what? Positive y and negative y. Now remember, for you to resolve a vector, you're going to resolve them into the horizontal and vertical component, each of them at the same time. Okay, now if I want to resolve these four vectors in the horizontal component, I'm going to resolve each of them at the same time, recognizing the ones that fall in the positive side or in the negative side. Very, very important. Okay, so as I'm moving to resolve it, I must recognize the positive and the negative. So let's go. Very, very simple. So we have that my x, which is the horizontal component, I'm going to start from here, right? So if I start from here, remember that I said that any vector inclined to the horizontal is inclined at angle of what? 0 degrees. Please don't forget. Now let's go. This is 3 Newton, right? And horizontal component goes with cos. Horizontal goes with what? Cos. So let's go. So this is 3 cos 0. Now why is it cos 0? Because it is on the horizontal, angle is what? 0. Any vector that falls between this side of x, they are all what? Positive, because they are in the positive side. Including this is also what? Positive. Do we understand? Okay, so let's go. I will say plus, this is what? 10 Newton, and the angle inclined is what? 30. The question is, Why is the 10 Newton carrying an angle of 30? Because all angles must be inclined to the horizontal. All angle must be inclined to the horizontal. So let's go. This is equals to 10 cos 30, right? Now plus, look at this, 3 root 3 is inclined as angle of 90, which is right angle vector. I told you it must be inclined at 90. So this is 3 root 3 cos 90. Now the last one is what? Plus, it is the negative side of x. I'm going to take minus. So this is bracket minus 6 cos 60. Do we understand? So let's resolve all through and get our final answer. So let's go. This is 3. Okay. Now cos 0 is equals to 1. Now plus, this is 10. Cos 30 is equals to what? Root 3 over 2, because it's a special angle. So this is multiplied by root 3 over 2. Okay. Now plus cos 90 is what? 0. So everything here changed to what? 0. Okay. Now plus multiplied by minus is minus. Alright. Now we have 6. Cos 60 is what? It's same thing as times 1 over 2. Is that clear? Now this is equals to 3 plus, hope you're getting it now. This divide this, I have 1. Divide this, you get what? 5. So this is 5 root 3, right? Now plus, okay. Now this is 0. This is 0. Now this is divide. This will give me this and give me what? 3. So I have what? 3. Remember that this is minus 3, right? Now automatically this will cancel this, right? So my x is now equals to 5 root 3 Newton. That is my horizontal component x. Do you get it? So let me look for the vertical component y. So let's go. Now going to the vertical component, all the vectors that are in the positive side, they are all positive. Why this one is the only one that is what? Negative. So let's go. Still starting from this. And remember that vertical goes with sine. So let's go. So this is, we go 3 sine 0 plus 10 sine 30 plus 3 root 3 sine 90. I hope you are getting, because they are all in the positive side of y. Then minus 6 sine 60. Do we understand? So let's resolve it. Sine 0 is equals to 0. So everything automatically changed to 0 here. Now plus sine 30 is 1 over 2. So this is 10 multiplied by 1 over 2. Now plus. Now this is 3 root 3. Sine 90 is equals to 1 multiplied by 1, right? Minus is 6. Sine 60 is what? Root 3 over 2 multiplied by root 3 over 2. Okay. Now this cancels this to give me what? 3, right? Okay, so what do we have? And this cancels this to give me what? 5. Now, remember, the equation will change to be 5 plus 3 root 3 minus 3 root 3. Do we understand? So automatically, this cancels this, right? Now, my y is equals to what? 5 Newton. So this is the resolution of these vectors in the vertical component. So let's solve for the main resultant, okay? We are going to use Pythagorean theorem to do that. So watch out and see what we are going to do. We have this. Okay, so my vertical is 5 Newton and my horizontal is 5 root 3 Newton. So let's go. We're going to complete it. But our intention is just simply to solve for the resultant, nothing more, not for the direction from the question. So we can join it. This is the resultant first, right? Okay, this is the resultant first. So using Pythagorean theorem, we have what? R square is equals to F1 square plus F2 square, right? So this is R square is equals to, what's my F1? My F1, I will use 5 square plus my F2 is 5 root 3 all squared. Is that clear? So now my r square is equals to 25 plus, by the time you square this you have what? You say 5 square times, when you square this have what? 3. Okay, now this is r square is equals to what? 25 plus, this is 25 times what? 3, which will give me 25 plus what? 75, which is what? 100. Okay, now my r square is equals to root of 100. Now therefore it's going to give me 10 Newton. Do you understand? So the resultant of these vectors inclined at a point is equals to 10 Newton. From what we got so far, the correct option to this particular question is option B. I hope that is clear. So let's go to the next one. Now let's look at this question. 2 points on a velocity time graph have coordinates bracket 2 seconds, 5 meters per second and 4 seconds, 15 meters per second. The question says calculate the mean acceleration between the 2 points. We have option A 5 meters per second square, option B 0.83 meters per second square, option C 1.50 meters per second square, and option D 2.00 meters per second square. Now let's solve. We're first going to write our coordinates. We have bracket 2 seconds, 15 meters per second, and we have 4 seconds. Sorry, this is 5 meters per second, and this is what? 15 meters per second. Okay, now, so what you are going to do, now if you remember that acceleration is change in velocity over change in time, so let's go. Now this is acceleration is change in velocity over change in time, right? So what is my change in velocity? So A is equals to final velocity minus initial velocity over the change in time becomes t2 minus what? T1. As simple as that. So this is the first point, okay? So this becomes my T1, while this is what? Initial velocity. Is that clear? Now this is what? My T2, while this is what? Final velocity. Is that okay? So let's just substitute it into what we have to get our acceleration. So let's go. So my V is equals to 15 minus 5, okay? Now from what I have, what's my second time? I have 4 minus what? 2. Do we understand? So by the time you subtract, you're going to have 10 divided by what? 2. And 2 into itself is going to give us 1. 2 into 10 is going to give us what? 5. So now from what we have got so far, my acceleration is equals to 5 meters per second square. Is that clear? Now going by what we have, the correct option to this question is option A. A uniform meter rule AB balanced on a knife edge 60 cm from end B when a load of 22 grams is kept 10 cm away from end A. What is the weight of the meter rule? Okay, now option A is 40 grams, option B is 55 grams, option C is 66 grams, option D is 37 grams. Now let's look at this question. This question was asked in 2023, so let's see how we can solve it. Okay, now the question says a uniform meter rule AB. So that means our meter rule is AB. This is from here to here. I have what? A, and I have B. It is balanced on a knife edge 60 cm from end B. Where is end B? If this is meter rule, this is 0 and this is 100, okay, centimeter. And if it happens to balance on 60 cm from end B, so 60 minus 100 is going to be 40. So that means the pivot or the fulcrum is going to be placed at 40 centimeters. I hope that is clear. So we're going to place it here, which is at 40 centimeters. Okay, so the distance between this B and where it is placed becomes 60. That is what they mean by that. So let's go. When a load of 22 grams is kept as 10 cm, now we have a load of 22 grams. This is 10 cm over here. They kept a load of what? 22 grams. Now what is the question? Where do we place the mass of this meter for us to get the weight? Now we're going to place it at the rightful center because a meter rule has a center of gravity to be at 50. So that is where it's supposed to be. Okay? We're going to place it at 50. Now it's going to be here. This is what you're looking for, right? So clockwise moment equals anti-clockwise moment. So this is what? Clockwise. Know how your clock moves. This clockwise. So that is why here is clockwise, okay? Clockwise from here to this pivot. So if you ask what is pivot, a point where turning effect occurs or where turning effect takes place, okay? Now, when you get to this point, it's going to do what? Turn to continue from up. So this is clockwise moment. Why this is anti-clockwise moment. Do we get it now? Now this is clockwise moment, while the other one is anti-clockwise moment, okay? Now the distance from this to this is what? 10. That is 50 minus what? 40 is going to give us what? 10. Do you understand? Now the distance between 40 and this is going to give me 30. Do you understand? So let's go. So you know that moment is the force multiplied by perpendicular distance. So this is m multiplied by distance is what? 10. Then it's equals to this is what? 22 multiplied by what? 30. Do you get it now? Now if you divide both sides by 10, this cancels this, so you're left with what? M. Okay? Now 0 cancels 0, you're left with what? 22 multiplied by what? 3. Now by the time you multiply, it's going to give us 66 what? Grams. Do you understand? So the weight of this meter rule is what? 66 grams. The correct answer so far is option C. I hope that is clear. A load of 300 Newton is to be lifted by a machine with velocity ratio 2 and efficiency 60%. What effort will be applied to lift the load? Okay, option A is 100 Newton, option B is 150 Newton, option C is 250 Newton, and option D is 400 Newton. So let's simply see what we can do. Now from this question, we have that the load is given as 300 Newton, okay? Then the velocity ratio VR is equals to what? 2. Then the efficiency is equals to 60%. Now we are looking for the effort. So let's solve. For us to solve this question, we must remember that efficiency formula, right? The efficiency is equals to what? Mechanical advantage divided by velocity ratio. So that is it. So we have efficiency is equals to MA over VR then times 100%. Is that clear? Now, what is my efficiency? That is 60, okay? Now this becomes 60 over 1. So what am I even looking for? That is the first thing. I'm looking for the mechanical advantage because effort is embedded inside what? Mechanical advantage. Is that clear now? So let's go. So we have MA over 2, right? Now multiplied by 100 over 1. So if you do cross multiply, this is going to give me cross multiply, that is 100 MA is equals to 120. I hope that is clear. And divide both sides by 100. This cancels this, right? So my mechanical advantage is equals to 1.2. Remember, it does not have any SI unit, so let's solve for the effort. Now for the effort, we have MA is equals to the load to the what? Effort, okay? Now my MA is 1.2, then is equals to my load is 300 divided by what? Effort, right? Now this is over what? When we say cross multiply, 1.2E is equals to 300, okay? And divide both sides by 1.2. This cancel this. So E is equals to 300 divided by 1.2, which is going to give us what? 250 Newton. You can now see how I solve it clearly now. I hope that is clear. From what we've got so far, the correct option is option C. I hope this video was able to help someone out there. Please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share for other people to see these videos and be able to watch it and learn from there. I will see you next time in the next one, and stay tuned for the next episode. Bye for now.